So the spans of the CLT range from about 15 feet to around 18 and a half feet. My name is Paul Cunell. I'm a project director at O'Day Engineers in Providence, Rhode Island. We're the structural engineers of record for this Brown Brook Street Residence Hall project. And today I'm going to speak to you a little bit about the structural system for this hybrid steel timber project. So the structural gravity system of this building is it's a steel timber hybrid project. So it's got steel columns and beams, as well as CLT floor panels. There are 4 lines of steel framing down the length of the building. Basically the 2 exterior walls and more or less flanking the corridor. Spanning to those lines of framing are 5-ply CLT. So the spans of the CLT range from about 15 feet to around 18 and a half feet. Some of those longer spans are encompassed within double to triple span panels. The CLT is being used as a diaphragm. So each of the CLT panels is connected with a spline, a plywood spline connection. So we have lateral force resistance system elements located throughout the building to limit the diaphragm force into the splines. So the vertical lateral system, the force resistant system for the building is a combination of CMU shear walls as well as steel brace frames. So as needed, we have used a series of fabricated steel drag straps fastened to the top of the panels, connected back to either CMU or the steel lateral force resistant systems through a series of angled clips fastened back to the CMU or directly fastened to the steel framing system. In these projects, in these hybrid design projects, both of the materials, we try to use both of the materials to their strengths, using the steel framing for ease of mechanical penetrations through the horizontally, as well as mechanical penetrations vertically through the CLT. They sort of work together to provide a structure that optimizes both of their strengths in that way. Now, in terms of like the vertical penetrations through the CLT, we work with the CLT fabricator, manufacturer, to locate panel spline joints not only at the gravity system, at columns, but also at mechanical penetrations so that we can maximize the size of the penetration within the panel span layout, particularly at some of our larger openings. Some of the lessons learned, I think, on these projects is with the 2 material types coming together, it's really important to make sure they can kind of stay out of each other's way and really pre-plan for as much of the openings particularly around columns. Having column grids that are uniform and aligned really makes a difference in terms of the ease of erection, the ease of panel layout, and maximizing the efficiency of not only the system itself, but how fast it can be erected. So I think my biggest takeaway would be having a regular and efficient column grid goes a long way to maximizing the efficiency of this project.